Owls are nocturnal,
Change in
which
momentum.
makes it difficult to see them when we're driving, and more likely that they're going to get hit by a vehicle. What happens when an owl is hit by a vehicle?
Is momentum equals mass times velocity. And for change to occur in momentum, either the mass or the velocity of an object must change. Because the object in question typically does not change its mass mid-motion, change in momentum is typically due to a change in the object's velocity, so it's either sped up or it's slowed down. So if a velocity is changing, then changes in momentum must be caused by acceleration. So we can amend the formula for change in momentum to be momentum. A change in momentum is mass times velocity, or a change in momentum is equal to mass times final velocity minus initial velocity. So I just want you to take a note of a small change in our formula where instead of it just being momentum, it's now a change in momentum. So a change in an object's momentum also requires a force. So force equals mass times acceleration. We have the formula for mass as momentum divided by velocity. Acceleration is velocity divided by time. So the formula for force we need to change momentum can be written as change in momentum divided by change in velocity times the change in velocity divided by time. We can cross out those two velocity units because they would be the same, and we simplify this as force equals a change in velocity, a change in momentum divided by a change in time. And this formula, again, will be in your data booklet. So we have two formulas to find the change in momentum, and it depends on the information given in the question. If we both have mass, and final and initial velocity, we can use momentum equals mass multiplied by final velocity minus initial velocity. If the force in the time interval is known, we can use a change in momentum is equal to force multiplied by time. So we use these equations to determine forces during collisions. So during a collision between two objects, we use the formula force equals change in momentum divided by change in time to determine the force exerted by one object onto another. Based on the time it takes for that change in momentum or collision to occur, as both objects involved in the collision for the same length of time and are applying force to one another. So our first practice problem, we're going to look at a 2.1 kilogram barn owl flying at a velocity of 15 meters per second east, strikes head-on with a windshield of a car traveling 30 meters per second west. We're going to calculate the change in the momentum of the owl. So to calculate the change in momentum, first we're going to list the information that we have. The mass of the owl is 2.1 kilograms. The initial velocity of the owl is going to be positive 15 meters per second. And I'm going to change this north to east, even though both would be a positive. They would both be a positive velocity. So the plus sign is appropriate, but it's east. And the final velocity is negative 30 meters per second west, the opposite direction. So now we're going to calculate the momentum. We're going to use the equation mass equals final velocity minus initial velocity because that's the data that we have. So we're going to take final velocity mass of 2.1 kilograms multiplied by negative 30 meters per second west minus 15 meters per second east. And we're going to determine the change in momentum is negative 95 kilograms times meters per second west, because that's going to be our final direction. So that same 2.1 kilogram barn owl, it's flying at the velocity of 15 meters per second east, strikes head-on with the windshield of the car again, moving 30 meters per second west. Now we're going to do this if the time interval for the impact was given at 6.7 times 10 to the negative 3 seconds. Determine the force acted on the owl. So the data that we had our original change in momentum at negative 95 kilograms times meters per second squared west, or meters per second west, a time interval of 6.7 times 10 to the negative 3 seconds, and we're going to calculate our force. So negative 95 kilograms times meters per second divided by 6.7 times 10 to the negative 3 seconds gives us a total force of negative 1.4 times 10 to the 4 newtons. Now it's negative because this force was acting to stop the owl and instantly changed its direction. So lastly, we're going to predict the effects of the collision on the owl and the car. Now, as you can assume, the owl will most likely be killed, while the car will only have surface damage. This is because not only did the owl have a smaller velocity and a lower momentum, the owl also had a lower mass contributing to its lower momentum, so it's going to apply an insufficient force to the car to change the car's momentum. So when we're looking at changing a momentum, if we rearrange the equation, we can get a change in momentum is force and the change in time. So if we can change momentum by changing the force exerted on the object or changing the time it takes for that change to occur. So in the illustration, the owl illustration, because the truck has a mass and velocity, it has momentum, the damage to the collision is dependent on the amount of force and time of the impact. So the greater the force or the shorter the time that this occurs in, the greater the change in momentum. If we think back to the previous sports example, what made hockey the most dangerous was the large change in momentum of the hockey puck compared to the smaller change in momentum for either the soccer ball or the tennis ball. So again, they're also both flexible objects, which make that momentum change longer. A collision occurs to the impact of one object with another, and in this case, the collision of a puck with the hockey player. The greater the change in momentum, the more the serious damage of the collision. Now, in a vehicle accident, the change in momentum is affected by force and time. So, in order to reduce the momentum in a collision, one of those two things has to be reduced to make cars able to handle collisions better. One is change the force. The only way to reduce the force in a collision is for the driver to travel at a slower velocity. And this is not in the manufacturer's control. This is in public government control. So this would be why school zones have lower speed limits than regular city roads, because if there is a collision, we want there to be less force due to the smaller nature of the people who are typically in school zones. And this is why there's often maximum speed limits on highways, because this is where the risk factor is that communities, counties, and governments have put in to say, our roads, due to the width of the lanes and the availability of room for vehicles to move, this is the fastest possible safe risk that we're willing to take. So if acceleration goes down, velocity goes down, and then force will go down proportionally. So we can change the force by driving more slowly. We can also change the time it takes for a collision to occur. So automotive manufacturers have invested in crumple zones in vehicles. So the crumple zones increase the amount of time it takes for the car and the passengers to come to a complete stop. Therefore, this helps to reduce the force and minimize the damage to the individuals in the car.